Now, let's move on to question 29. What is the structure of HCO3 minus? Okay. Sometimes I think I'm scrolling down on this side, so that I kind of already start scrolling down the answer by accident. But structure of HCO3 minus. So for this one, like I said, I think it'd be better to just leave out the hydrogen to begin with, just in case. Okay. So what does that mean? It means we're going to try to solve, I guess, CO3 2 minus then, because hydrogen always adds an extra electron. Whoops. Yeah. CO3. No, it would still be CO3 minus, because all you're doing is kind of like that. Trying to think about this. Yeah. We actually just, in fact, you know what I said? Let's actually first find out from the periodic table the values for it in terms of the electron configuration. For carbon, start with helium again, 2s2, 2p2. Oxygen is start again with helium, 2s2, 2p4. Okay, so now we know, and you know, hydrogen is just 1s1. That comes in later, but point being, we want to calculate for everything. So that's 1 plus 4 plus 6 times 3, that's 18, and then plus 1 more. Okay, so that's 18 plus 18 plus 4 plus 1, not the hydrogen, but that extra 1 there. So we have 23, well, we technically have 24 electrons in total. We're going to solve it like the hydrogen's not there. So we're looking at CO3 minus. So we want to at least account for 23 of that 24. So CO3. I'm just going to put carbon in the middle like this as a start. Okay? Because it's sharing 1 each with the oxygen. At least this is the theory so far. Okay? And now we're going to see how many valence electrons are left. So oxygen here is sharing 1 of its 6, so 2, 3, 4, 5, 6. Same with this one, 2, 3, 4, 5, and then, yep, 6. 2, 3, 4, 5, 6. And now carbon, of its 4 electrons, it's sharing 3 of them, so it needs 1 more. And there's that extra one as well. That one, I think, to make it make sense, because we want to form at least 1 double bond, because all carbon can handle. So we're going to form a double bond here. Okay. And that's going to be C, a double bond here. And now we still have, this really gets tricky, right? Because right now we have only 22, I believe. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 20, 21, 22 electrons. Yes. So put those over there. That will make a double bond there. And then we still have this. If we filled out 1, because that's negative, right? We actually now have space for the hydrogen. It would actually go here. Okay? But point being, though, is that we would have, if we redrew it, C, give it a little more space, C, O, another oxygen here, another oxygen here. Okay? Double bond, 2 more. And then this was gonna have that one like this, and this one is gonna be like that. Okay. So with that being said, this is what we have so far. So now we have space for the hydrogen, okay? Because this one's still that 1 extra electron that was left after we added the other, the 23rd one. So this is where the hydrogen comes in, like that. So this actually is a structure for HCO3 minus. And if we did the actual math for in terms of like the electron number, carbon exactly likes 4 minus it's sharing 8 electrons. Whoops. 0 lone pairs sharing 8 electrons. So that does indeed equal 8, 0. So now oxygen, let's try this left side first. It'd be 6 minus, okay, just to make sure I'm doing the math right. 6 minus, it has 4 lone pairs plus 4 over 2 because it's sharing 2 there, also equals 0. Okay, and now for the oxygen with the hydrogen, it's going to be 6 minus 4 lone pairs, and it is sharing 4 electrons, so it's also going to be 0. The hydrogen, I'm specifically doing that oxygen in the corner last, and you'll see why. Okay, so the hydrogen is 1 minus, okay, sharing 2 of them, so it does equal 0 as well. Now for the last oxygen, we have 6 minus, okay, it actually has 6 lone pairs plus sharing just 1, well, 2 electrons. That's going to be a minus 1. And there is where our negative is going to be. Right there. So, this and the whole thing is, yeah, minus 1. But exactly, this is going to be our Lewis structure for HCO3. Let's see how we did. Well, HCO3 minus. Specifically, one of the oxygens is going to have that negative charge, and everything else is neutralized, and the hydrogen is actually sticking on the oxygen, not the carbon. Wow, we did it. Yep, and a double bond right there. Ooh, nice, we have it all. So double bond, one of the oxygens has the hydrogen, and then that's what the negativity is. So this is correct. I always get a little bit scared because it's hard to notice double bonds, but exactly, we have 4 electrons being shared right there, so that exactly is what the double bond is. Okay, that's correct. Now move on to the last question for today, question 30. Okay,